Find the partial fraction decomposition for 8x plus 7 all over x squared plus x minus 2. The first thing we're going to do is factor the denominator. So we have 8x plus 7 all over the quantity x plus 2 times the quantity x minus 1. Notice these are distinct or different linear factors. And for each distinct linear factor, we're going to get a partial fraction. So we're going to have one of our partial fractions have a denominator of x plus 2, and another have a denominator of x minus 1. And what goes above each of these is a constant that we don't know yet. So we're going to put the constant a above x plus 2 and the constant b above x minus 1. And what we're doing in this process is we're trying to find those values of a and b. So we want to be able to add these two partial fractions back together to get the original rational expression. So let's do that generically with these unknown a and b values. So to add rational expressions back together, we need a common denominator, which is going to be quantity x plus 2 times quantity x minus 1. So we'll multiply the top and bottom by x minus 1 on the left partial fraction, and we'll multiply the top and bottom of the right partial fraction by x plus 2. So these now have common denominators, and so we can add them back together. So if we add these back together, they are going to be one rational expression with x plus 2 times x minus 1 as the denominator, and a numerator of a times the quantity x minus 1 plus b times the quantity x plus 2. And remember, we're trying to find these values of a and b so that when I add these back together, I get back to the original rational expression. So what that must mean is that the original numerator, so 8x plus 7, must equal a times the quantity x minus 1 plus b times the quantity x plus 2. So this is the equation, 8x plus 7 equals a times x minus 1 plus b times x plus 2, that we're going to be focusing on to solve for the values of a and b. And we're going to do this using two different methods. Alright, I've made some room here. So we have our equation 8x plus 7 has to equal a times the quantity x minus 1 plus b times the quantity x plus 2. So the first method we're going to use is building a system of equations. To start this process, I'm going to distribute in the a and the b. So I'm going to have the equation 8x plus 7 is equal to ax minus a plus bx plus 2b. Alright, and so now what I'm going to do on the right hand side is recognize I have some like terms. So ax plus bx, I'm going to put those next to each other. So I have 8x plus 7 is equal to ax plus bx, and then I'll put minus a plus 2b also next to each other, because these are also like terms. They don't have any x's. So on the left side, I have one term involving x, and that has an 8 as its coefficient. On the right, I have two terms involving x, and one has an a and one has a b in front of it as its coefficients. So I'm actually going to think about factoring the x out of these two terms and rewriting this as a plus b x. So I'm just focusing on the terms involving x right now. So on the left, 8x has to equal what's on the right, a plus bx. So if these are truly equal, 8 has to be equal to a plus b. The coefficients in front of x on the left have to equal the coefficient in front of x on the right. So I have 8 is equal to a plus b. Now let's take a look at the constants. On the left I have plus 7, and on the right I have negative a plus 2b. So anything that doesn't have an x has to be equal to one another. So 7 has to equal negative a plus 2b. Now what I have here is a system of equations. And to solve a system of equations, I can use either substitution or elimination. This one is set up nicely to use elimination, where I just add the two equations together, because then a minus a will cancel. So if I add these two together, 8 plus 7 is 15, a minus a is 0, b plus 2b is 3b. Solving for b, divide both sides by 3, I get 5 is equal to b. And then I would substitute b back into either equation. I'm going to substitute into the top one. So 8 is equal to a plus 5. So subtract the 5 to the other side, I get 3 is equal to a. So I found those values of a and b, but those by themselves are not the answer. What we have to do is remember how we originally set up our partial fractions. All right, we had a over x plus 2 and b over x minus 1. So our answer is substituting in a above x plus 2, so replacing a with the value we found of 3, and then replacing b with the value we found of 5. So our original rational expression can be broken down or decomposed into these two smaller partial fractions. Now we're going to do the same problem using a second method. So we have this equation, and the second method is to choose x to eliminate a term. So if this is truly an equation, then the left side has to equal the right side for any value of x that we choose. Well, we're going to cleverly choose specific x values to help us solve for a and b. We're going to start by choosing x equals 1. If I let x equal 1, then if I focus on this term right here, 1 minus 1 is 0. And so that would eliminate this entire term involving a. So the idea is that we want to look at the factors that we have in the two terms on the right, and we want to think about what value would make that factor equal 0. If necessary, solve it. So you can kind of go off to the side and say, what would make x minus 1 equal 0? X equals 1. We want to let x equal 1. And then plug that 1 into each x value in all of the terms. So we would get 8 times 1 plus 7 is equal to a times 1 minus 1 plus b times 1 plus 2. So we have 8 plus 7 is 15 is equal to, well, 1 minus 1 is 0, and then 1 plus 2 is 3, so we get 3b. Then divide both sides by 3, we get b is equal to 5. So I showed a lot of work here, but the idea is that we want to try to do a lot of this in our head, because the values that we choose are going to zero out a term, and we want to maybe be able to do mental math for the remaining terms. So let's try it again to find the value of a. We're going to think about what number would I need to plug into x into this term involving b so that it ends up becoming a 0. Well, negative 2 plus 2 is going to give me 0. Again, if you need to, you can solve. What makes x plus 2 equal 0? X equals negative 2. So let x equal negative 2. Okay, so let's do this with a little bit of mental math this time now. If I plug in negative 2 times 8 is negative 16, plus 7, that's negative 9, is equal to negative 2 minus 1, that's negative 3, so negative 3a. And again, negative 2 plus 2 is 0, so the b term is gone. So to solve this equation, divide both sides by negative 3, since this is multiplication here. So we're going to get a is equal to 3, which we did already know, right? So we still get the same answer where a went above, so 3 went above x plus 2, and then 5 went above x minus 1. So we should still get the same answer.